The search for alien life around us has been going on for almost 4 decades, but scientists have not been able to grab some solid evidence about it. However, with the advancement of technology, we humans can now peer back into the virtual origin of our universe. And with that, we have learned much about the laws of nature that control its seemingly infinite celestial bodies, their evolution, motions, and possible fate. Yet, equally remarkable, we have no generally accepted information as to whether other life exists beyond us, or whether we are alone in this never-ending universe. So are we really alone in this wide universe around us? Let's find out. Welcome to Mystery Hub, where we unravel the deepest and darkest mysteries of the world for you. In today's video, we are going to talk about a possible sign on alien life detected by a Mars rover. So if you want to know more about it, then stay with us until the end of the video. When imaging locations where extraterrestrial life could potentially dwell, few places inspire the imagination like one of Earth's closest neighbors. For centuries, man has looked to Mars and imagined it as a home for other beings. Over the last 50 years, various missions to the Red Planet have sought to determine the probability of such an evolution. But how likely is life on Mars? To prove the existence of life on Mars, various missions have been sent to the Red Planet, and one such mission is the Curiosity rover, which is currently studying the surface of Mars and collecting samples for scientists. Curiosity landed inside Mars's 96-mile-wide Gale crater in August 2012 on a mission to determine if the area could ever have supported microbial life. The rover team soon determined that Gale's floor was a potentially habitable environment billions of years ago, harboring a lake and stream system that likely persisted for millions of years at a time. In the new study, the research team looked at 24 powdered rock samples that Curiosity collected with its percussive drill from a variety of locations between August 2012 and July 2021. The rover fed this material into SAM, which can identify and characterize organics, carbon-containing molecules that are the building blocks of life on Earth. The scientists found that nearly half of these samples were enriched in carbon-12, the lighter of the two stable carbon isotopes, comparable to previous measurements of Mars meteorites and the Martian atmosphere. These high carbon-12 samples come from 5 different locations within Gale crater, all of which featured ancient surfaces that had been preserved well over the eons. On Earth, organisms preferentially use carbon-12 for their metabolic processes, so enrichment in this isotope in ancient rock samples here is generally interpreted as a sign of biotic chemistry. But carbon cycles on Mars aren't understood nearly well enough to make similar assumptions for the Red Planet finds. Defining the carbon cycle on Mars is absolutely key to trying to understand how life could fit into that cycle. We have done that really successfully on Earth, but we are just beginning to define that cycle for Mars, said Andrew Steele, a Curiosity scientist. Therefore, the researchers came up with 3 possible explanations for the intriguing carbon signal. The first involves Mars microbes producing methane, which was then converted into more complex organic molecules after interacting with ultraviolet light in the Red Planet air. These larger organics then fell back to the ground and were incorporated into the rocks that Curiosity sampled. But similar reactions involving UV light and non-biological carbon dioxide, by far the most abundant gas in Mars's atmosphere, could have generated the result as well. It's also possible that the solar system drifted through a giant molecular cloud rich in carbon-12 long ago, the researchers said. All three explanations fit the data. Study leader Christopher House, a curiosity scientist based at Penn State University, said in the same statement, "We simply need more data to rule them in or out." So the study is going to continue, and scientists will need to see if a similar carbon signature is present in other sites of Mars that are known to have well-preserved ancient surfaces. Scientists also want to analyze the carbon content of a methane plume released from the red planet's surface, but that is only on the possibility of Curiosity encountering such a plume. So, apart from carbon-12 found on Mars, what more evidence of extraterrestrial life has been gathered to date? Fossilized worms. It has been revealed that the carbon-12 found is not the first claim of alien life. On August 7, 1996, the then U.S. President Bill Clinton stood on the White House lawn and announced the possibility that scientists had discovered the ancient fossilized remains of microorganisms in a meteorite that had been recovered from Antarctica in 1984. The meteorite, ALH 84001, is one of a handful of rocks we have from Mars. These were blasted off the surface of the planet by volcanic eruptions or meteorite impact, drifted through space probably for millions of years before ending up on Earth. The tiny structures discovered within, using powerful microscopes, resemble microscopic worm-like organisms that are likely to be billions of years old. Debate over the true origins of these structures continue today. Many scientists have pointed out that well-known inorganic processes are quite capable of producing structures which resemble living organisms. In other words, simply because something might look a bit like life, mushrooms or otherwise, that does not mean it is. Mystery gas.
On August 20th, 1975, the first Viking spaceship was launched.
In the 1970s, NASA's Viking robotic landers carried a series of experiments designed to test the Martian soil for the presence of microorganisms. After the chemical analysis, each soil sample was steadily heated to hundreds of degrees to destroy any microbes, with the intention of seeing whether any such reactions in the soil ceased. Intriguingly, this particular experiment did show a steady increase in carbon-14 over time, which was indeed terminated after heating to above the boiling point of water. More recently, minute quantities of methane have been found in the Martian atmosphere. This is also intriguing, as living organisms on Earth are known to release methane. Once again, however, it must be stressed that this is not conclusive proof of life. Methane can also be produced by several inorganic processes, including by heating rocks. Mushrooms. A recent study claims to have found evidence for mushroom-like life forms on the surface of Mars. As it happens, these particular features are well known and were discovered by cameras aboard NASA's Mars exploration rover Opportunity shortly after it landed in 2004. They are not in fact living organisms at all, but hematite concentrations, small sphere-shaped pieces of the mineral hematite, and their exact origin is still debated by scientists. Hematite is a compound of iron and oxygen, and it's commercially important on Earth. The spherical rocks on Mars may have been created by the gradual accumulation of the material in slowly evaporating liquid water environments. They could have also been produced by volcanic activity. Either way, mushrooms they are not. The area around Opportunity's landing site is littered with them. They can be seen all over the surface, and were also found buried beneath the soil and even embedded within rocks. So, the research done by Curiosity has not only revealed how the Martian climate changed, but also helped Perseverance determine which soil samples to collect to increase the odds of finding life. we've learned something very important. There are some parts of the Martian rock record that aren't so good at preserving evidence of the planet's past and possible life. Co-author Ashwin Vasavada, a Curiosity Project scientist at NASA's Jet Propulsion Laboratory in California, said in a statement, "The fortunate thing is, we find both close together in Gale Crater and can use mineralogy to tell which is which." The search for life on Mars has been given fresh impetus by a new study that could have triangulated the possible location of the 6 methane emissions detected by Curiosity Rover during its time in Gale Crater. Since all of the methane in Earth's atmosphere comes from biological sources, scientists are thrilled to find the gas on Mars. In summary, we have positive results from various missions and their analysis of the red planet. All of these discoveries about the planet provide tantalizing hints of the possibility of life in the early history of the red planet. But a more thorough examination of the surface has the potential to reveal even more insights in the evolution of life on Mars. And who knows, we may be reaching our final piece of the puzzle in the search for alien life. And this is it for today. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.